大家好，现在我给大家讲一讲冯立叶变换的事情。首先，我先用中文讲，然后再用英文讲一遍。然后，首先什么是冯立叶变换？Fourier transformation. Okay, let me use some different paper with now in this kind of format. It can make the looks more concise and neat. Okay, so the first thing, what is Fourier transformation? First, we need to understand what is transformation. It is hard to say, but transformation is what we can use one way to express something. We can use a simple way to express something hard to explain. It's called transformation, and they can convert to each other. For example, we have a coordinate. For example, we have a vector, which is A. This is a vector, and the coordinate of the vector is maybe it's 2, 1. For example, we have a vector A. Its coordinate is 2 and 1. But this is 2 and the ordinate is 1. Okay, and we also have, and this is we use in this the vector in these coordinates can be converted to A. This is called transformation. Because we use this kind of way to express a vector in the coordinates, it is more easy and it can be used for calculation. It can make our calculation more simple, and it will be helpful in the real practice. This is called transformation. And also, they can be converted to each other by direction. For example, the vector can be in the coordinates can be converted to the a point, and we use this kind of way coordinates, and also this way this point, this vector can also be drawn in those coordinates. Also, and we have another point called B. For example, this is 2, 1. Okay, this is 1, 2. Okay, we have another. It's called B. Okay, B. It's 1, 2. And also we can do the calculation. For example, A, P means C, 3, 3, and also C could be also calculated in the real can be calculated in the coordinates. So it can be this transformation and inverse transformation, and those points, those vectors can also be drawn reverse transformation to the coordinates, so they can be converted to each other. Okay, and in this coordinates we have something. For example, we have EY, EX, and this EY, and they are called orthonormal basis, and we can use two vectors to represent any vector in one coordinates system. So but sometimes we use an orthonormal basis. Also things like EX, vector EX and XEY. First, they have these requirements. First, EX dot the product of the X and the EY. EX dot product EX equals EY. EY dot product of them equals 1. And also the EX, the product of X and EY, the vector, two vectors equals 0, because they are perpendicular to each other, and the angle between them is 90%. Yeah, so it's so the cosine of the 90 degrees is 0. So the dot product is 0, and the EX EY is called orthodox basis, and we use the basis to represent of them, because every any vector could be used to, it can make out the expression for others vectors more simple, because we use the also normal basis. Yeah. Okay. Second, we told what is the Fourier theory. We used for the Fourier series. What is Fourier series? It is usually proposed by the Fourier, the mathematician and scientist, the French scientist, and it would be a assumption proposed by the Fourier, and it's true. It has been validated by the mathematician afterwards, after the Fourier, and the assumption is any assumption a periodical function could be converted to the summation of a series of sinusoidal or cosinusoidal functions. Yeah, so it's any function. Periodic function could be converted to a sinusoidal or cosinusoidal functions. For example, we can give you an example. There would be a periodic function. For example, it's like this. Yeah, it's like this. It's and no, it's one period. It's not a sine function. It's a standard sine function or cosine function, but it's periodical. It's periodical. So, for example, we have this, and this is in time domain. It's t. This is the t, and this is the ft. So, and that means we could use by the Fourier series. That means this periodic function could be converted to several summation of a series of sine or cosine functions. For example, we can convert it to some sine functions. For example, we can that means we can draw the sine function with this original function in the same plot. For example, we can, yeah. Okay, that would be for example, it could be this original function could be converted to 3 sine functions, and they have the different frequency and phase and amplitude. Yeah. So first one maybe like this. For example, it's the this is the sine function, and it has the frequency omega, and second maybe we have the another function. Maybe it's high frequency. The frequency is high. The two which is frequency of 2 omega, and also maybe we have another can be converted to 3, and another is the maybe it's more high frequency. So it's a 3 omega, and 3 omega. So it's 3 omega. So we have omega 1, omega 2, 1, 3 functions. So that means, and this is the time domain. And this if we look this plot in this direction, we know that it is in different frequency. It has those original function could be converted to several functions with different frequency, and this is the time domain. This is called frequency domain. This is the timing domain. Also, if we look this way, we can get the function like this. Okay, this is the omega, and we have the amplitude. Maybe it's a1, and also it's omega 2. Maybe it's 2 omega, 2 omega a2, and also omega 3. This is the third sine function. We have this. Okay, S3. And also this is one thing. So amplitude, we know the amplitude, the frequency, and also we know the phase, the initial phase, the phase of the, because for example, at this moment is the standard, is a standard sine function. If for example this is 0, for example this is maybe it's 2 pi, we don't know that. Maybe we can assume the zero phase is, for example, maybe just phi 1, phi 2, and phi 3. So that means the initial, the original function ft could be converted to such a, for example, we can there is a ft could be converted to several functions, to several sine functions. For example, so sine this one, sine omega a1, no, it's a1 sine t, and phi 1, and second is the a2 sine 2 omega t and phi 2, and 3 1 sine 3 omega t dot phi 3. And also maybe there is something to there is a number. It's a number. Maybe it's 0. Maybe it's everything. For example, can a lin that's a 0. So we could so that means so this is one how to say, that's one special case for that. In generally speaking, ft could be expressed for the Fourier series. The ft could be expressed by the common formula is that a ln the a ln per a ln over 2 plus the summation of the an. This thing is the amplitude for each sine function, and the sine function, and n omega t, and for that, for each sine function, this is the frequency and also the phase. And yeah, and also this also could be expressed by this way. This is the constant, and also, and because any sine function could be expressed by the summation of a sine function and a cosine function. So it could be an sine n omega t and bn sine, no sine, cosine, it's cosine n omega t, and that would be, so we can also, from this we can get also normal basis 1 sine n omega t or cosine n omega t. This is three sine is the three thing of that. This is the three thing of the all three also normal. And also this is the Fourier series, and you know, any, that means any functions, periodical functions could be expressed, can be transferred to a function expressed by these three three elements of the orthonormal basis. And then I will told you about the what is we told the transformation and the Fourier series, and then we told you what is the Fourier transformation. What is the Fourier transformation? What is the Fourier transformation? What is the Fourier transformation? Because what is Fourier transformation, and Then first we need to go to the also normal basis. What is not? Because for also Fourier transformation, it means first we need to define the orthonormal basis, to use the orthonormal basis to express everything in that in this case. For example, we can use this way to express the orthonormal function. For example, first for any point A, have a vector A, have a coordinates, and the abscissa is the, for example, this angle is theta, and this is because one, the unit circle with cosine theta, and this is this is the real part, and this is the imaginary part, and this is I sine theta. So for any point, A could be expressed by cosine theta plus I sine theta by the Euler formulation. This could be transformed to E I theta, and also the theta could be mapped with the time t, the omega t. So E omega t E minus omega t, and that means this is the t means the for example the t, when the t increase, the theta will be increased. So this is the counter clockwise, and this is clockwise. And clockwise, this for example, and if we use this way, we will know that we will know we use when the t in different t, we can get different in the whole domain, in the whole domain we can get all the for one t we could get a pair, get a group of orthonormal basis. But for orthonormal basis, and for one t we could get a group of bases. But when the t increase from 0 to 2 pi, we can get what? We can get infinite. We can get infinite increase. We can get infinite. When can get infinite also normal basis, and that could be used in the following. Then we could use that. For example, what is Fourier transformation? This is one group of the orthonormal basis. For example, there is the original signal like this. It's not periodical. It's just a common. It's a general, and it have no there is no periodical. It's not a periodical function. But I want to do the transformation. That means this is the transfer function. This is Fourier, and we can do this. We can do the the integration from the negative infinite to the positive infinite, and the ft, and also the ft will be multiply times this one. For example, if we have we use this, we will test the in this domain in every t, for example, we will test, we will test the in every t, 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 in every t in every t. The domain, the in this, the omega, and the result of this when it's equals ln is no omega. In this period, there is not equals ln, that is omega. There is omega. Like this, so it could be used, and we can use the t to check that. Yeah, that could be true. So this process is called information ft transformation, and also we can do the otherwise, and the result of that, for example, we can do part. One is the real part. This is the real part. Once this is real part, we can get the omega. Real part. The real part. This is the frequency, and this is the frequency, and this is amplitude, and also we get the imaginary part. That is, for example, the imaginary part, and this could be used as the, for example, what is imaginary part? Imaginary part means the imaginary part is the is the I, and the theta would be, for example, this is real, and this is EI. The theta would be cosine theta would be the real part sorry, not that, tangent theta means the shape, the I R and the theta equals arc tangent. Yeah, that is the phase. That is the phase. Okay, you can get that.